Hello and welcome to this little tutorial on BPMN gateways. Today I'll be discussing 4 incredibly useful gateways and 1 abomination that should not be in the standard, but it is, so I'll just talk about it at the end. For each gateway, I'm going to discuss sort of 4 factors about it. The first is how it works when it's splitting, how it works when it's merging, how execution works, how you might execute that things, and also some use cases, times when it's a good idea to use it, and some little tricks about ways in which you can get really interesting patterns with those gateways. So yeah, I'm going to start off with the XOR Gateway. So let's go. We are now in the Camunda modeler. A link to the SaaS version or desktop version is available below. It's also free to use, so you don't need to pay for anything. And you can model along with me if you like. Now we're going to start off with the database exclusive gateway splitting, also known as the XOR. Now that's a very long name, it's good it's shortened, but that name actually carries with it a lot of explanation about what the gateway is supposed to do. It's data-based, so not all gateways are based on data, some don't need data, but this one does. It's exclusive, which means that following the gateway, only one flow will be activated, so it can only leave through one sequence flow. And it's splitting because it splits the flow. So if I were to select this start event, which would be start process, and I add a gateway, it is an XOR. This is the big X in the middle. That is a thing. All gateways have this diamond shape, and the XOR has this little X in the middle. So how does it work? Well, given some kind of data, it's going to decide to go one way or another. So we could say something like is email required, right? And we have 2 options. 2 different tasks we might go to. One might be send email, and then if you don't have an email, then you might have send fax, for instance, because everyone has a fax number. And then I'm going to say that this is a user task, and this is also maybe a service task, or whatever. So how does this work in terms of usability? Well, the first thing is we need a variable, and this is using some kind of Boolean, and this is going to be a yes and a no. And the way this works in terms of token simulation would be we start a process. If the email is required, we go one way. And if the email is not required, we go another way. It's pretty easy. And this is how the gateway splits. Now, you can have more than one branch, and we'll talk about at the end. But generally speaking, most use cases, XOR gateways tend to be used to evaluate Boolean expressions and send the process one way or another. Now, after we send our email, we want to send some kind of product to the person. And let's say that this is going to happen whether we send them a fax or an email, right? And this is why we use merging gateways, because after we split from here, we want to return here in one flow. And the best way to do that in this case with an XOR gateway is to add another XOR gateway. And you link them like this. Now what this does, this is a merging gateway, right? And the way the really simple thing, they look identical and they are identical. So you might be wondering, like, how do I tell the difference? Really simple, just look at the sequence flow that leaves it, right? The gateways actually are identical. They work the same, the merging and the splitting, but it depends on the sequence flows leaving because they follow the same rule, right? The rule is that when a token arrives here, it leaves from exactly one position, one sequence flow after, right? Now, if there only is one sequence flow, well, then it'll just always go that way. So you don't need to, it's going to ignore any kind of criteria. It's going to say, well, I've got one way to go out, so I'll go that one way. There's no other way I can exit. So in this case, we can see that this takes in 2 flows, and then there's one exit. So it doesn't need a label. It doesn't need to evaluate anything. Instead, what it does is no matter which way we go from this gateway, it will then end up going to products in the end, even if we go the other direction as well. So it's a way of like merging 2 flows together. Great stuff. And we can also have multiple ways of exiting this, because right now we have a Boolean, right? Now I've talked about that's the most common use case, but it's not the only one. And in fact, when you're not using a Boolean, there's some things you could consider. So let's imagine instead of, let's say, is contact required? And let's say they had an option to either fill in an email address, or they had a fax address, or they had they don't have either, right? So we would say this would say email was selected, right? And this would say fax was selected. Now, why is that different? Because now we have an option where it's possible, right, that we actually could have neither of those. We could have something else, right, because it's no longer a Boolean. So in that case, I'm going to introduce you to a really important part of understanding gateways, which is a type of flow called a default flow. So in this case, now what will happen is if neither are applicable, so if it checks and evaluates both and neither are applicable, we just go around it. This is really, really useful for when you're using gateways that don't have Boolean values. In terms of execution, let's pop into implementation here. We've got a load of X's and things. So in implementation, it'll ask me for how to do this. So if this were a Boolean, there's two ways I could do it. I could say email, which is a variable called email that I would expect, equals true. Great. So if email is true, we go this way. And then down here, we might have email equals false, right? Great stuff. Now, if we were dealing with a variable, like say a string rather than a Boolean, well, then we could like have something similar to, let's say, contact equals email. And then this one would say contact equals fax. And now you can understand that the default flow then catches everything else. So if it's not an email, it's not a fax, we go this way. It's pretty easy. Okay, and that's kind of how to use XOR gateways. So let's move along. Let's head back to design and let's move on to our next gateway. Our next gateway is, again, I will put it right here. Oh, the suspense. It is a parallel gateway. So a parallel gateway is not database, a much shorter name. The real name of a parallel gateway is also parallel gateway, and doesn't need data. It's not exclusive. It just runs things in parallel. So after we send the product, we are going to, let's say, inform the warehouse, and also inform, let's say, book pickup. Okay. So here are two things that need to happen, and they don't need to rely on each other to happen, right? So we can quite easily say, okay, that informing the warehouse about something and also booking the pickup can happen in parallel at the same time. They don't need to talk about each other at all. And the gateway is pretty easily understood because all it does is, if we have a start event here, once the token starts, it'll go here and it'll just basically do both things, right? It's pretty easy. It always does both things. You can also, same as the XOR gateway, you can have loads of things. We'll talk about that in a few seconds. As many as you like in parallel. And that's what always happens. No label needed, no execution needed. The thing about this gateway is, with the XOR, it's very front-loaded in its complexity. The splitting does all the work. Parallel gateway, the merging is what's really important, because after informing both of those people, we need to go on a coffee break, right? And once both are informed, we can do that, but we can't go on a coffee break until both are informed. And so we can't connect these two like this, because this gateway, as we discussed previously, is a merging XOR, and this will actually cause some problems because in this case, it will actually just send both tokens. So we will go for 2 coffee breaks that will happen, which is not the end of the world, but not the best, not very good for efficiency. Instead, this gateway merges with this gateway of the same type, which is a parallel gateway. Pretty easy, right? And the way the parallel gateway works, the merging one, as I said, does most of the work. It is going to wait for the tokens to arrive. So we can see here, we wait for one. When the second one goes, we go forward. Now, here is the key thing about parallel gateways. The thing that is very, very important to know is, how does it know to wait, right? So in this case, we started our process. It sent 2 tokens. This one is waiting, but why is it waiting? A really interesting mistake people tend to make is they assume that it's waiting for the number of tokens that left, which isn't true. Just like in the XOR gateway, the trick is to look at the sequence flows. So this has 2 sequence flows leaving, great, so 2 tokens will leave. But this is waiting for 2 sequence flows to arrive in, right? So that's really key, because then a pattern you can do is, while in parallel to informing the warehouse and book the pickup, you may also just check the mail. Now, checking the mail is not something that's going to stop you from going on your coffee break, which means now if we do this, we send 3 tokens, right? One goes here, one is here. Now, a really cool pattern here is that because this is only waiting for 2 tokens, because one from here, 2 sequence flows, once 2 arrives, it continues. Meanwhile, this branch is still active, so we can check our mail whenever we're ready and then finish it. It's a pattern that only exists because we know that this gateway doesn't know about this one and is waiting specifically for 2 tokens to arrive. Most deadlocks in BPMN happen because people don't realize how the symbol merges correctly. In terms of execution, well, it doesn't need much actually, or any. The execution just functions. You just connect the symbols and it works. There's no additional execution required. So that's quite an easy one. And remembering the patterns is really important. Remembering that this is waiting for the number of sequence flows, number of tokens equal to the number of sequence flows, and has nothing to do with splitting, is a really important way to be able to build your processes. So that's parallel gateway taken care of. Okay, that is 2 down, 2 to go, so we're halfway there, and we're going to go into our next gateway, which is the inclusive OR. It looks like this. It's got a little circle in the middle, and it functions, it's a database gateway, so just like the XOR gateway, it needs some kind of data, but unlike the XOR gateway, it's not restricted by the number of tokens that leave. So for instance, we could, we have this lovely thing here, which usually doesn't deal in a Boolean because it can send a token through each sequence flow that abides by some kind of condition. So for instance, let's say we're making coffee and we want needs milk, because there's our coffee break, or needs sugar, right? So there we have 2 different things. Now, an interesting thing about the labeling here is that, generally speaking, if we go back to our XOR gateway, we had a question on the gateway and then usually an answer to that question. Inclusive gateways don't always need that because sometimes the sequence flow has enough information to let you know. Also, because the sequence flow can be basically independent from each other, they may not even have a question that is relevant to all of them. So this would be add milk and this would be add sugar. So the interesting way this works is similar to a parallel gateway. It'll send multiple tokens, it can send multiple tokens, and similar to an XOR gateway, it needs to evaluate the condition first. So let's just add this. So in this case, both are on, so we're going to have both milk and sugar. Fantastic. And then we're done. And we could also have one or the other. Maybe I just want sugar in my coffee. But of course, I actually like black coffee, so I like mine completely black. The merchant gateway for this is the same gateway once more. And similar, this actually combines what the XOR gateway merge and the parallel gateway merge does, in that if it's waiting for a single token, one don't go through. If it's waiting for 2 tokens, and it's usually based on the number of tokens produced by this gateway. And so in this case, if we wanted, let's say, just sugar, it'll go down here, add sugar, and then continue. If we wanted both, it should wait for both. There we go. Now, it's not very important to know exactly how it does this, because each engine that implements this is kind of different. But basically, the execution is very, very similar to parallel, except that it's kind of aware of the tokens that it's waiting for. That's all you need to know. Now, I talked already about how, what if I don't want anything at all in I want black coffee like I always do. You can do this and have a default flow. So now this means that if anything doesn't match, If both of these are ticked no, we automatically go this way. It's a nice pattern. So this is a catch-all again, if nothing matches. There's another interesting criteria we can do, which is what if we just want to pour the coffee as a task? Well, what we can do is you can have pour coffee, and it wouldn't make sense to make this a default flow because default flows only trigger when nothing else matches. But instead, we can have an always flow. This is a really nice pattern. So this would just be always true. So we would just basically always go this way, and sometimes add sugar and sometimes add milk. Right, so we'll always add the coffee. It's a really nice pattern for when you want to do one thing for sure, and you might do other things in parallel depending on criteria. So let's take a look at the implementation. For an always flow, it's really easy. Just say true. Fantastic. It's also really handy to stop deadlocks because in this gateway you also must go to between 1 and n. You have to leave at least one position. Needs milk is exactly the same as it would be for a gateway. Milk equals true for an XOR gateway, and sugar would be sugar equals true. The difference between this and the other gateway is that these are usually independent. They don't have to be, but usually you're evaluating different expressions independently that don't rely on each other in any way. Yeah, and that's how you would build the inclusive OR gateway. So let's move along. I've saved the prettiest gateway till last, and it is the event-based gateway. Hurrah! So I hope you folks are looking forward to this one. So the event-based gateway is really interesting. It's not data-based, so it's not like the exclusive gateway, but it is exclusive. So only one token is going to leave. So how is it doing that? It basically does that by having a weird rule, which is after this gateway can only be catch events in BPMN. Now I've done a little video before about events and catch events. And so I won't go into too much detail, just to add these two types. One is a timer event, which waits for a certain time, let's say 1 hour. And the other one is a message event, which waits for some message to come in. And that is like, alarm or whatever. So the way this works is you connect these two like so. And when the token arrives, it basically waits right here on this gateway until one of those two things happen. Now, just like other gateways, you can have as many as you like. You can have lots of events after it. 2 is just the one I'm dealing with right now. And when the gateway arrives, it's waiting for both of those things to happen in parallel. So it's waiting for them in parallel. But as soon as the first one happens, the process continues and it stops waiting for the other one. So 2 tokens can never be produced here. It's always the first event that happens. And so the way that would work would be, we would start our process, we wait here, and let's say it's been an hour, so we continue. Or maybe after 3 or 4 minutes, the alarm goes off, so then we have to go there. So it's pretty easy, and you can add as many events as you like. I would look into the different event types. The only catching event you can't use here, I think, is probably the error event and compensation, but most other events like signals or conditional events are all possible here. But how to merge this is kind of interesting. Every other gateway has been pretty obvious. If we look back, we have the XOR gateway needed an XOR gateway to merge it. The parallel gateway needed a parallel gateway to merge it. And inclusive is inclusive. The issue with this is because of that weird rule about it needing an event after it, we actually can't really merge it with an event-based gateway, right? Because then the next thing we produce has to be a gateway or has to be an event, right? Which doesn't make a lot of sense. So instead, we need to merge this with an XOR gateway. The reason is really simple, because we're just merging multiple flows back into one. So this thing basically works like this because it's exclusive. So only one token is ever going to arrive, and that's how that gets merged. So the way that works would be, we start our process, rock on here, the hour is triggered, and we're done. It's pretty easy. There's loads of really good reasons to use this. This is a prime example where you're waiting for a certain one of two things to occur and one to continue. Almost always a timer is a good one, because otherwise you might get stuck in a deadlock. So do have a timer if you can. If you don't, you could have a problem where you have your message waiting for like two signals, a doorbell or alarm. And if neither of those happen, the token is going to be stuck here forever. So do have a think about always adding a timer event here to avoid a deadlock. In terms of execution, you don't really need to do much here. All the implementation really happens on the event side. So you would add a duration here, for instance. So maybe PT1H for an hour. And then you would add the various message types here. But the gateway itself does not need any particular execution, so it just works based on what's configured on the gateway. It's a very, very useful gateway, looks really great, and really important if you're waiting for let's say 2 or more things that may happen and you only want to act on the first one. So that's where this gateway is most useful. Finally, the last, I've talked about 4 useful gateways and 1 abomination. So let's talk about it very quickly. You will see this, the complex gateway in the modeler, because it's part of the standard. It's not implementable and it basically does magic. The idea here is this is a gateway that's a catch-all for stuff that the other gateways can't do. Don't use this. It's just really annoying, and it hides a lot of complexity, and there's really not a lot you would need this for, but I thought I'd mention it anyway. Now, what I will do is I will talk through all the gateways. I'll connect up this lovely model, and I will talk through exactly how they run. So let's connect these, and let's talk through from the beginning how these gateways run from token simulation. Okay. So we have an XOR gateway, which goes exactly 1 position, leaving it. And then once we arrive there, we have a parallel gateway in which we're waiting for multiple things that may occur, in which multiple things can happen in parallel. Once both arrive, we will continue. Then we have an inclusive OR, which will match up all of the individual sequence flows that are relevant, as well as an always if we want. It'll evaluate them all individually, so you could get parallel, you could get single, but once all arrive, we arrive then at the event-based gateway, at which point one of these events may occur, doorbell goes off, we then merge back into a single flow and continue. That is all the gateways of relevance. So thank you very much for watching, and I'll see you next time. Cheerio, bye-bye.